Hello everyone and welcome to our webinar presented by Veolia Water Technologies and brought to you by Coal Publishing and Treatment Plant Operator Magazine, also known as TPO. My name is Anthony Drew and I'm the digital editor for TPO. In this webinar, titled Leveraging Your Data for Predictive Wet Weather Management, you'll learn how Veolia's Hubgrade Performance digital service brings together the collection system, treatment plant, and weather radar data streams to provide a holistic approach to wet weather management. During the webinar, you'll be able to submit questions. In your control panel, you'll see a series of drop-down menus, including one titled Questions, and that's where you'll submit. At the end of the presentation, our panelists will answer those as time permits. Afterward, they'll send responses to all the questions asked by those attending the webinar. Now I'd like to introduce our panelist, Mark Drake. Mark has been a water professional for 25 years. He obtained his BS in chemical engineering from Iowa State University in 1998 and has held PE designations in Wisconsin and North Carolina. Much of his career has focused on process engineering and product management for several fixed film and activated sludge EBNR systems. Mark has taught many wastewater certification courses through the years for NC1 Water, where he has also served on and chaired the association's Wastewater Operators School Committee. Mark has been part of Veolia Water Technologies since 2010 and has held the position of Digital Services Manager since 2021. Mark is focused on leading digitization efforts for Veolia in the U.S. market through application of the company's Hubgrade digital services platform. And with that, I'll turn the program over to Mark.
Okay, thank you very much, Anthony, and thank you everyone for attending today. I'm looking forward to sharing this information with you. To start with, we'll talk a little bit briefly about some wet weather challenges. I'm sure most of you will already be familiar with those types of challenges, but we'll just have a little refresher on those. And then we'll talk about, well, I have a question to pose, and it's can you leverage your data? And that will, of course, lead to how we leverage wet weather data in collection systems and at treatment plants, and that's with our Hubgrade Performance platform. And that will lead us to a discussion of the power of inflow prediction and how we utilize those predictions to best optimize collection systems and treatment plants. And we'll wrap up with some questions and answers that Anthony will lead us through. All right, so when we're looking at collection systems and we're looking at wastewater treatment facilities, those operations face a lot of challenges. At large macro level, we're dealing with climate change, we're dealing with environmental regulations. There's certainly community and social pressures that come into play and impact how you need to operate systems day to day. On top of that, most communities are dealing with aging infrastructure, they're dealing with tight budgets, trying to do more with less, and there are all kinds of capital projects and other ways to try to address problems and deal with these challenges, from separating sewers to eliminate CSOs, to sewer linings and replacement, to adding new retention basins, adding equalization basins, finding those sorts of ways to deal with wet weather. And at treatment facilities, clarifier expansion is another infrastructure project that is often undertaken to deal with wet weather issues. So with all of those challenges that many of our facilities and collection systems are facing, we ask ourselves, is there another way besides just infrastructure that we can solve the challenges we're presented with? And that leads me to ask the question, can you leverage your data to help address those challenges? Well, there's lots of different kinds of data. Some facilities, some collection systems operations have more data, some have less data. There's generally some set of sensors installed in manholes, installed in treatment facilities, installed in pipes, and that leads to data collection. Today, there's almost an infinite amount of data that we can derive from the various types of sensors and use that data in a variety of different ways. But how can we maximize our use of that data? The key is we need to bring value to data, and that's at a first level. We have people who look at that data and make decisions, right, on how to best operate collection systems, when to open a gate, when to close a gate, turn on a pump, turn off a pump, when to undertake various operations in the treatment plant, et cetera. So that's a first level of how we get some value out of that data. And we also then make decisions that allow us to change operations, maybe bring a clarifier online that was offline, again, adjust some gates, pumps, et cetera, to deal with situations in a very reactive sort of way. But we can also take it to another level and incorporate real-time optimization. And so these are all ways to solve challenges. And in order to leverage your data, from our perspective, the real key, what we're trying to accomplish is bridging that gap between all this data that we can collect and then what is it that we can do with it to best utilize that data and solve those challenges that you're dealing with in your collection system and at your treatment facilities. So can you leverage this data? The good answer is yes, you can. Advanced digital solutions are delivering results out there in a variety of different ways. And in general, when we look at the data that we're gathering, we're now able to get that with tremendous speed. We can feed that into our control systems and our optimization systems and allow staff to focus on strategies, and we can build optimization systems that focus on strategies rather than just repetitive tasks. And we can affect how things operate. We can go out into the network that controls pumps, valves, et cetera, and we can adjust configurations. We can do things in virtually real time. So that's one way that yes, we can leverage that data because we're getting the data in speed and we can affect changes with a high level of speed. Well, one of the key ways that we utilize that speed of data transfer, that speed of change out in the system is by making predictions. And that's what we'll focus on quite a bit here today. And that takes us to a place where we're anticipating changes and affecting the operations of systems rather than just being purely reactive. In particular, when we are dealing with wet weather, there is a tremendous amount of value that is gained from being able to accurately predict how that rainfall is going to impact the collection system, being able to predict where flows are going to be, what the magnitude of those flows are going to be, when are they going to hit the treatment plant. So we bring a prediction. We're able to utilize predictions with the speed in which we get data and are able to go back out and affect changes in the systems. And so that allows us to really affect the capacity. We have a great capacity for affecting change now, and we can do that on a fairly broad scale in a holistic way in the entire collection system and the treatment facility, or we can do it in a very narrow manner in just certain key locations, certain key operations in a facility or out in the collection system. In either case, we're able to deal with millions of inputs per day, bring in that information, process that information, generate predictions, and take concrete, proactive steps to optimize based on that information. And we've already been deploying systems that do this, and we've seen a great deal of results with this. In Veolia's experience with our Hubgrade platform in applying predictive optimization, we see 85% reduction in combined sewer overflows in the systems where we've deployed, an increase of up to 100% in hydraulic capacity. And by that, I mean how much flow during those peak wet weather events can you get through a treatment facility, get through the clarification. And by being proactive in how we deal with wet weather events, we can increase the hydraulic capacity significantly. These lead to the opportunity to reduce CapEx costs. We've seen facilities that have, in a new clarifier project, say, been a bit more able to be more aggressive with the design and reduce the size of the clarifiers being installed. We've seen in collection systems plans for adding retention basins, getting some wide spots out there in the line to hold up a little bit of flow. We've seen the need we've seen the ability to eliminate some of those capital costs, eliminate some of that concrete. And then this leads to a reduction in operational and carbon footprint in our facilities as well. So how do we do that? We do that with our digital service called Hubgrade Performance, and there are two modules. There's Hubgrade Performance Sewer and Hubgrade Performance Plant. I'll generally just refer to it as Hubgrade Performance. It is a consistent platform that affects both the sewer system and the treatment facility, so it's fully integrated, but it is able to be deployed in just one or the other or both situations to optimize the collection system or the treatment plant or both. We certainly can affect change, and you can see a broader and better optimization and better handling of wet weather when both modules are deployed, but they are able to be deployed independently. So what is Hubgrade Performance? It's an online digital twin of the sewer network and the treatment plant. It enables the operating teams to make informed decisions related to the facilities and also optimize in real time the operation thanks to the data that we're getting and the predictive analytics. Today, with Hubgrade, there are over 100 references. The majority of that are focused on the plant portion and dealing with optimizing treatment facilities. So it is proven, it's replicable, it's secure. I would note that the reach of Hubgrade Performance goes far beyond just optimizing wet weather. The Hubgrade Performance Plant for your treatment facilities feature many different, has many different features that allow you to optimize BNR processes, optimize chemical feeds for feeding polymer, for solids thickening, optimizing supplemental carbon addition, optimizing BioP in treatment facilities, adding BioP to facilities that don't currently have dedicated anaerobic zones, those sorts of things. So there's a wide range of solutions on the Hubgrade platform for wastewater treatment, and there will certainly be other opportunities for learning about those, but today we're going to focus more on collection system and treatment plant in the wet weather aspect. So again, over 100 references overall, over 60 references in Europe, very similar climate to here in the US and Canada. And we have a very high level of built-in cybersecurity, been approved by agencies around the world for implementation. It is a cloud-based service. We work through Amazon Web Service, but we can follow up if there are any detailed questions about the cybersecurity aspect, and whatever a given facility's protocols, I'm 100% certain that we can meet those protocols in a safe and effective manner. So I want to talk just briefly and very generally about traditional control methods for how we operate collection systems, how we operate treatment facilities. In general, you can see here the blue line represents, it could be flow, it could be the feed rate of a chemical, it could be the pumping rate. It could be any parameter really that varies in time based on, how much is coming into the collection system from the homes and businesses in your community. Well, the traditional way of operating a facility, you have to have a certain safety factor above that in terms of, how you run pumps, how you operate clarifiers, et cetera. And you have set points that an operator will put in place. There may be some level in certain cases, level control or flow pace control for pumps and things. But in general, you're operating in this sort of stair step, reactive. Okay, at some point that a given parameter, influent flow, et cetera, changes enough that now a new set point needs to be put in, and maybe that's manually put in, or maybe it's something that has a level of automation through a PLC. But you maintain this pretty significant gap between how the control is functioning and what's happening with any given variable in real time. Well, the difference between the operation according to those sorts of set points and the reality of what's happening with a given parameter represents, room for optimization. And when we look at a typical wet weather operation without any form of predictive optimization, and you have rain, you have a storm, you have inflow, and you have infiltration, you have water traveling through the collection system to the treatment facility. You're limited in how much control you have. Pumps are going to come on and off based on some unknown amount of flow that's coming into manholes, and eventually, that's all coming to further and further spots, coalescing down the line. You risk overflows if you do have combined sewers. You risk a CSO, maybe you're risking SSOs, and ultimately all that flow, hits the treatment plant. And you can have certainly some knowledge knowing that a storm is coming and manually choose to take some steps that may help you weather that storm. But you're still, really quite reactive. And once that flow hits a treatment plant, really the big concern there is when you send those high flows through your activated sludge system, through your clarifiers, which is what the majority of treatment facilities have, you're risking sludge escaping. You're risking clarifier washout of solids. So the big question is, can we affect a better optimization with predictive control? And we can. So the standard way of running equipment at treatment facilities, the standard way of running equipment, gates, valves, pumps out in the collection system is typically PLC-based operation, which are simple local decisions, a lot of sort of if-then logic, ladder logic, and again, it's very reactive. Well, there is an opportunity there for a smarter way to control, and that's where Hubgrade comes into play. The simplest way to put what Hubgrade actually does from an optimization standpoint is it's an optimization layer that goes on top of existing controls. It doesn't change the general nature of PLC control. When a facility implements Hubgrade performance solutions, there's generally not, PLC programming changes. It works with existing set points. And what it's doing is in real time, based on the data that feeds into the algorithms, and that includes flows and level and various things, and rainfall information, et cetera, depending on exactly what feature we're talking about. New set points are determined in real time that anticipate where things are going to be trending. based on that digital twin, based on that model, and then takes action to change set points in real time to allow the system to better respond when it does see those changes. So the limitations of PLCs create an opportunity to provide this additional optimization layer, and that's what we're doing with Hubgrade Performance. And in a general sense, what you end up with is actual operation that much more closely aligns with how things are actually changing in the collection system, how they're actually changing at the treatment facility. So when we look at it in a wet weather context, and you have rainfall that's projected, what you do with Hubgrade will be to identify whether it's a CSO outfall location, or whether it's a particular spot in the collection system, or if it's at the influent of the treatment facility, where you have flow monitoring or any form of flow meter or level in a pump station, for example. The data that's being collected, which includes those parameters, as well as data from rain gauges, data from weather radar, is feeding into Hubgrade, which is generating predictions of where those levels, where those flows are going to go. And the ultimate predictive optimization features can then adjust set points for gates, for valves, for pumps in the collection system to do a couple of things. So Hubgrade will look to proactively create room if you have retention basins, if you have, where you have large pipes. It can clear out more volume in advance of the storms during dry weather. So basically prepping it so there's more capacity to hold flow. That's a key way by which you can reduce the risk of CSOs or SSOs with Hubgrade Performance. And at the treatment facility, there are a number of different tie-ins with the RAS system for your clarifiers, with the main aeration tanks that will prep the treatment facility to handle those high wet weather flows that it knows are coming in the near future. So we'll talk a bit more about that here as we go forward. So to bring it back to how we're leveraging that data with predictive optimization, the first step is getting that real-time data, collecting it, bringing in water level and flow. And these are really the key things when it comes to wet weather prediction. Water levels and flow rates, some amount of rainfall data, and it may be just a simple single rain gauge. As long as the system is able to get that data to the communication software that gets it to the cloud, then we can use that data. And then weather forecast data. Now the weather forecast, it is possible Hubgrade Performance does function without the weather radar element. It can create predictions and proactively optimize with just level and flow input and some rain gauge data, but it isn't as robust of a prediction and doesn't give as good of a look out, 1 hour or 2 hours, say, from when that storm is going to hit. It doesn't give as good of a look as when weather radar data is tied in. Now, the weather radar data itself, that comes from a variety of different sources. At Veolia, we have an internal weather system that uses IBM derived weather data, but really any weather API, if there's something local that is available on the web. That data, as long as we could get it, it can be used. So that all leads to generating a next level of information, and that is a forecast for rainfall, forecast for at particular locations. If we're monitoring rain gauges, then we're predicting how much rainfall is going to fall there. Generating overflow statistics, generating fractionations in pipelines to show how much inflow there is, how much infiltration there is, so we know exactly what is coming from water outside the pipe and getting in, both during dry weather and during wet weather events. And all of those have various alerts and things tied in with them. And the next level is then KPIs, key performance indicators associated with the flow forecasting. This gives us the opportunity to also, when we're monitoring the pumps in the collection system, to take very close looks at pump efficiency in real time and be able to identify and predict if there's something going wrong with a pump. And then ultimately, the real key is the inflow forecasting and then the real-time optimization that we're able to derive from that inflow forecast. And I've mentioned the ways that we affect the operation and collection system and the treatment facility to optimize and prepare for wet weather and to get that wet weather through with gate and pump optimization or operation, flow diversions, equalization, RAS control, and aeration tank settling. That is, a big part of how you are able to process high wet weather flows with minimal risk, or certainly greatly reduced risk of any clarifier washout. And that's how, with the prediction and knowing when and how much flow is going to hit in the future, being able to predict that, you're able to automatically have preparatory steps taken to manage the mixed liquor in the plant, bring down the clarifier sludge blanket, build up some solids inventory earlier in the process in the aeration tanks, and minimize the impact of solids going out in the effluent. So let's take a look at some of the screenshots from the system itself. The friendly user interface, we provide a map of the collection system area, showing all the various control points and data points, of course. Being a cloud-based service, when there are updates to any of the features that are deployed in a given, for a given customer, those updates are automatically given. That's a strong benefit of utilizing a cloud-based platform as opposed to trying to do something that's strictly local. Is the ability to get regular updates. The system is always live 24/7. The operations staff has control over what users it assigns to the system and at what level users are assigned. And those users, depending on their level, get monitoring updates, get alerts. If a given user makes a change to something within the system, to one of the settings within there, it's always recorded, it's noted, so nobody's able to go in and change something without a supervisor or without others being able to know that something has been changed. Forecasts, of course, go into the system. We'll see an example of that here in just a minute. Email warnings, if you get a event that is predicting, say, a CSO, you're going to get an email warning about that. And then another very helpful feature, and this is actually a key to how we've grown the platform over the years, is there is what we call the R&D lab feature of Hubgrade. And this is applicable for both the sewer collection and treatment facility, unit operations, but there's the ability to tailor new or update or modify existing features to fit unique and specific situations that you might be dealing with, that could be a little bit different or haven't been, fully implemented before with Hubgrade performance. As a user, you are able to utilize that lab feature to do your own programming. You, of course, have to have somebody who's knowledgeable in programming. And of course, we are there to help and assist and partner and team with you to do that kind of customization. But if there's a unit operation that isn't well covered by existing standard features of the platform, you can develop your own digital twin. You can develop your own algorithms to optimize a given equipment item or a given unit operation, or add something to an existing feature. So it's highly flexible in its ability for you to customize and make the system fit your needs. There are a number of different reports and alerts that you are able to obtain as a user of the system for when we're talking wet weather. Again, when there's predicted flows, predictions happen at various time intervals, so you can constantly keep an eye on when the storm is coming. Those predictions out in 15 minutes and 30 minutes and 60 minutes and 120 minutes, and receive alerts and notifications. And you can set up customized reports that will summarize how the system's performing, show you KPIs, etc. So a very robust system to allow you to track how the system's performing and how it's optimizing the collection system and the treatment facility. I mentioned earlier the inflow and infiltration briefly. So with the sewer module, you can obtain a high degree of information about what is traveling through the pipes in your collection system, given sufficient data, and contrasting over time what's happening during dry weather, what's happening during wet weather events. The system, in a very smart way, can identify what is normal dry weather wastewater, how much flow at any given time is direct runoff, how much is constant infiltration, how much is indirect runoff. And for given locations in the collection system, you can see that fractionation. And the way our customers tend to best utilize that information is to help them prioritize and address where they may need to go look for blockages, where they may need to look for significant root intrusion, and identify where they're going to send crews so they can do it efficiently and minimize costs associated with going out and troubleshooting areas in the collection system. It works great to go along with a capital improvement plan to help lay out that prioritization. And as you know, capital improvement plans, they're a constant work in progress as you make updates and improvements and line a sewer here. Things are changing elsewhere in the system, and so you're continually updating that plan. Having access to this type of information will help guide you and prioritize how that capital improvement plan comes together and how it evolves over time. And the key to what we're really focused on today with the predictive optimization and the stormwater forecast, it's a real-time tool for estimating flows and water levels at pump stations, CSO locations, wastewater treatment plant influent. We really take a holistic approach, and as I said before, although you can deploy the sewer and the treatment facility functions separately, you obtain a much more robust ability to optimize the performance of your complete system during stormwater events if you have data and you are optimizing both aspects, the sewer and the treatment facility. This helps operators plan new strategies during events for the sewer system and treatment plants, and automatically make changes to best handle those wastewater flows. I've talked about how we prepare equalization volume, initiate aeration tank settling, etc. The graph at the bottom, this is just an example showing, what a given flow, say this is the influent flow to the treatment facility. You're generally going to have, maybe you have a flume, maybe you have a pipe with a magnetic flow meter. Essentially all treatment facilities, or at least most, have at this day and age, have some monitoring of influent flow. Even if you only say had effluent flow being monitored, that would still be able to be used, still be useful. It's not as direct a link as the influent flow to the plant, but it would still provide the same information, allow you to, you would be able to predict based on what's happening in collection system, where the rainfall is happening, how much. You're going to be able to predict. You're going to see that trend in the effluent just a little bit later than an influent, but you would still be able to predict that and be able to take actions before that would hit. But let's say this is the influent flow to the treatment plant. You've got the lighter blue thinner line being the actual influent kind of bumping around the place. Typically the predicted value is going to be a little bit smoother line, but that's going to depend on how robust the data is that we're gathering in the collection system, how many rain gauges we have. Do we just have a single one out in the collection system? And at any given time, how accurate is the weather radar data that we're getting? Weather radar data is pretty accurate today, but it's not perfect. And we all know, especially the larger facilities or the larger communities get, rainfall doesn't happen evenly across the entirety of the collection system. It's most of the time very local, and it rains in some area and doesn't rain in another. So how that lines up with where there are rain gauges and et cetera, that all affects, to some extent, the quality of the prediction. But even with the minimal input for rain gauges and with the weather radar data input, you can generate quite accurate influent or flow prediction, whether it's in the collection system or, as in here, influent of the treatment plant. And what this is showing, on the left in the white area is, history, and in the gray area is the future, is the prediction. And this band around the black line is essentially a confidence interval. And in general, the further out in time you're predicting, whether it's 1 hour in the future or 2 hours in the future, the accuracy of the prediction will be reduced. You expect, as you're much closer to the time that you're predicting, you get a better and better prediction. But there's still a lot of value to be derived from prediction 1 hour out, 2 hours out. And with Hubgrade performance, you can see those different predictions. So let's say here, I'm in Cary, North Carolina. We've been getting some rain recently. let's say as of right now, if I were looking at a Hubgrade performance system with data fed here in my local community, I would be able to see 1 hour out in time what the prediction is, 2 hours out in time what the prediction is, 15 minutes out in time, 30 minutes, 90 minutes, and that is continually updated. So I'm able to see both short and long range forecasts of what that inflow is expected to be. And if I choose to have automated optimization on and allow Hubgrade to change set points in my system, it will. If I want to, I can have that aspect turned off and just use the data, use the prediction as an additional level of information to make changes manually if I so choose. So from that standpoint, the operations staff always has power to choose how optimization is implemented, whether it's fully automatic or still requires operator input. This just sort of reinforces and shows a little bit more of a complete picture of what's happening with the forecasts, with the different data streams feeding. You've got collection system in weather radar data, rain gauge data, all feeding into the model. Again, it is a digital twin, so it's all feeding a model of the collection system, a model of the treatment facility, and generating a forecast saying, how's the flow going to change? When's it going to change? When's that wet weather going to actually hit the treatment facility, et cetera? And then that information can be used by the staff, and it can be used to automatically make adjustments. In regards to the treatment facility itself and clarification, I wanted to just really quickly show an example of what we're doing with the influent flow forecast at the treatment facility. The real key here in wet weather events is ensuring we're keeping solids in the system, ensuring we're not washing out solids from the clarifier. And the way that we do that is primarily through aeration tank settling. That's what the ATS is, aeration tank settling. So if we don't have aeration tank settling, we don't have any form of predictive optimization. Well, we have a certain capacity in the treatment facility where if we're just running and we're not taking steps to prepare, at some point when this flow really starts to go up, we're going to hit a point where we have a risk of washing out solids. However, if we take proactive steps and we implement aeration tank settling, and we do that based on our prediction of when the flow is hitting the plant and how it's going to hit the plant, we can grow that capacity and we can eliminate that risk of solids washout by getting the treatment capacity during that wet weather event to a higher level. Again, by allowing solids in the hour, in the 30 minutes, but whatever, before that storm, before the flow actually hits the plant, because we know when it's going to hit, allowing solids to settle in the aeration tanks and reducing sludge blanket depth in the clarifier, and then reducing the RAS rate so we have actually less velocity, less flow going through the complete system. And so we're trying to limit the flow to what's actually just coming in and going through the facility. And that's proven very effective in many, many plants to prevent solids washout and expand the capacity, increase the capacity of the secondary system. So I just want to wrap up here on the presentation with a very short case study, just a couple of slides. I'm not even sure I'd call it a case study, but just wanted to share, one real world facility in Denmark that has been a long time Hubgrade user. They have many features in the collection system and in the in the treatment facility, and they actually have 4 different wastewater treatment facilities. It's operated by Blue Colding is the name of the utility that operates the collection system and treatment for the city of Colding. They have combined sewers with many different pump stations, a lot of CSO locations, a number of storage basins out in the collection system. And again, they utilize Hubgrade in the collection system with predictive inflows, predicting what's happening at their CSO locations, allowing them to better manage that, and then also Hubgrade the treatment facility to better manage wet weather there. But they also have a number of features deployed for optimizing biological treatment and optimizing other aspects of the treatment facility. And they've operated for many years, and a lot of, I mentioned the lab feature and developing new features. They have been a great partner for us in developing new features that serve them, but that also can translate elsewhere, such as incorporating variable power pricing as an additional parameter in how things are optimized in predictive optimization in the collection system, and allowing a higher fraction of water to be pumped and treated when power prices are lower, and saving money. So they've seen a great deal of benefit with Hubgrade, both in their collection system and at their treatment facilities in handling wet weather. They reduced from pre-Hubgrade times to post-Hubgrade times, reduced overflows by 83% in their system, increased the hydraulic capacity at the treatment facility by 80%. And then they've seen a number of different benefits in terms of performance at the treatment facility, saving chemicals and saving energy. So you can certainly reach out to me, if you are in Canada, you can reach out to my counterpart, Martin Kaspar, for more information about Hubgrade performance. At this point, I am gonna kick it back to Anthony, and hopefully he's got a few questions for me.
Okay, thank you for the presentation, Mark. There's still some time to submit questions, and it looks like we have a few to get to. So I'll start with this one. How is the flow predicted at each point in the collection system?
So the flow is predicted any location where we have flow as an input. Say there's a flow meter out in the collection system, or at a pump station, there's a level probe. Hubgrade performance, it's building a stochastic. We build a stochastic model of the treatment or of the collection system. So there's basically a hydraulic model that's built of the collection system that operates in real time. That's the digital twin aspect. And so anywhere we have a flow or a level input into that, we will generate predictions of that variable out in the future, if that makes sense. So the model is running through various scenarios, and when we have, so it's utilizing what it typically sees when there are wet weather events. Say there's, we have rain gauge data. Okay, historically X inches of rain with an intensity of Y inches per hour. It sees this sort of impact on the level in this pump station, and we also have weather radar data tied in to the system. And so we know, okay, well, it's predicting this much, so we can predict what that rainfall raise is going to be, and then that leads to a prediction of what that level in the pump station or what that flow, where that flow meter is. So hopefully that answers that question reasonably well.
All right, yep, thank you. Our next question gives you kudos on a great presentation, and then asks, do you know how many installations there have been at drinking water treatment plants?
So we have not applied Hubgrade performance in a drinking water treatment plant. The Hubgrade performance features are really, they're focused on collection systems and wastewater treatment plants. We do have a number of Hubgrade services that we deploy in drinking water facilities. There are various smart clarification features that allow us to optimize chemical addition, optimize polymer addition, things of that nature at drinking water facilities. But specifically the wet weather predictive optimization, that's focused on collection systems and wastewater treatment.
Okay, thank you. Our next question, does Veolia have special sensors, or are a particular manufacturer's sensors required to be used?
So at Veolia, we are very sensor agnostic. All we really are focused on is the data and having the right data to enable a feature to give us meaningful and accurate predictions that can then positively affect the performance of the collection system, the performance of the treatment facility, et cetera. So when we are working with a customer, it's normal that they have a hodgepodge of different manufacturer sensors. One manufacturer level probes, certain brands of flow meters. Maybe they've added some, new smart sensors already out in the collection system in some locations. As long as we're able to get that data to Hubgrade, it does not matter who the manufacturer of the sensor is that generated it.
All right. Our next question, has Veolia deployed this technology on any systems in the United States?
We have. We have. Our experience to date is predominantly in Europe, and we've deployed the performance plant features in one treatment plant here in the U.S. thus far. There are more planned, and the collection system, we're currently working in the city of Milwaukee, and we've deployed that feature, the sewer features with predictive inflow to identify and predict. They have a huge underground tunnel storage system to help them manage their wet weather flows. Their collection area is very broad, very large, and they have 400 or 500 million gallons of storage underneath the city. And so we're working with them right now to identify how we can best manage that volume and capitalize on predictions of inflows into that tunnel system. So it's a pretty exciting project that we started earlier this year, or late last year.
All right. And with that, it looks like we're just about out of time. So a big thank you to Mark for today's webinar. Those of you in the audience will receive a recording of today's webinar and a follow-up email with instructions on how to reach out to our presenter with more questions. You'll also receive a link to certificate for CEUs. And thank you all for joining us today. And that concludes our webinar.